Good morning, everyone, and welcome to our live coverage of the latest operations from NASA's Kennedy Space Center. I'm Will Robinson-Smith, reporter with Spaceflight Now, and welcome into our live coverage of NASA's wet dress rehearsal tanking test for the launch vehicle you see here on your screen. This is the Space Launch System, or the SLS rocket. The Orion spacecraft atop this 322-foot tall stack out at LC-39B. We're broadcasting, as we always do, from the Spaceflight Now News Bureau here at the Kennedy Space Center press site. We're glad to have you with us for this portion of a roughly 49-hour and some change timeline, testing the 2+ day countdown leading up to what will be when they're ready for this launch day. But this is, of course, a test of all these systems and an assurance that they've got a good handle on the pad flow here at Launch Complex 39B and the fueling of this particular SLS rocket, which on launch day will carry 4 astronauts: NASA's Reed Wiseman, Victor Glover, Christina Cook, along with the Canadian Space Agency astronaut Jeremy Hansen, on a roughly 10-day voyage around the moon and back, ending in a splashdown off the coast of California. At around 11:25 a.m. Eastern, Artemis launch director Charlie Blackwell Thompson gave the go to proceed into fueling today. We'll be going back and forth between a couple of different times and timelines for this tanking test. What you see there on the upper right-hand corner of your screen, that is what is referred to as an L- clock. That is ticking down to the opening of the test window, which is at 9 p.m. Eastern. (0200 UTC for our friends around the world. The test could go as late as 1 a.m. Eastern, 0600 UTC tomorrow morning. Hopefully that won't be the case, but of course we will be here and present with you all to walk you through the major milestones of this all-important tanking test of the SLS rocket as we progress through this countdown timeline today. As we're getting going here, certainly want to thank all of you who are with us at the start of our coverage. I know it's sort of an odd time in the middle of Monday afternoon. But appreciate the nearly 400 of you who are carving out some lunchtime to be with us. You could do us a big favor by clicking that like button and sharing the stream to allow more folks to find their way into this WDR live coverage. I want to thank one of our channel members who's with us right now, Cumulus Granatus, for helping to answer folks' questions in the chat. We ask that as we progress through this coverage that you respect our live chat rules. We ask that you post your message in English so that our moderators can respond as appropriate. We also ask that you hold off from delving into topics of overt politics or religion, and please don't post in all caps. Emojis are perfectly fine. We just ask that you don't create a huge block of them so it takes up a large percentage of the live chat. Last but certainly not least, we ask that you treat each other with the kindness and respect that you yourself would like to be treated, and we'll all get along swimmingly. Of course, this tanking mission is in pursuit of the forthcoming Artemis 2 mission, which will not be a landing on the moon, so this mission doesn't have direct involvement from the two HLS or Human Landing System vendors, those being SpaceX and Blue Origin. Though both companies are working on their respective lander models for the Artemis 3 missions and beyond. To set some visual expectations for this coverage as we continue on through the count, we are getting limited views from NASA, in addition to our own cameras here at the press site. Also, NASA is not providing commentary on a technical feed as they did during some of the previous wet dress rehearsals during the Artemis 1 WDR campaign. And unfortunately, we're not expecting to get any of those pad-level engineering cameras. So if we think back to after the launch of Artemis 1 or even post some of the wet dress rehearsal tanking tests, we got those really nice up-close shots from the pad deck of the mobile launcher to give various views of things like the gimbaling of the RS-25 engines at the base of the core stage. Again, setting expectations for today. Barring some bulge from the blue, we are not expecting anything like that, at least during live coverage. Our photography team has been busily preparing for the flight of the Artemis 2 mission and is also standing by in support of the various camera views that we are able to offer, in addition to the feeds coming in from NASA, like this one you see here on your screen. Actually, want to correct my statement a moment ago. This, in addition to that side view of the rocket, this is also another NASA view here. This is a zoomed-in view that we have zoomed in, so we get a little bit tighter on the pad deck level, and hopefully we'll be able to see some of the signs of fueling as the liquid oxygen and liquid hydrogen begin to flow on board the rocket. I mentioned our photographers that are getting ready to support our coverage. If you're not following them on X, you can find them at the handles you see here on the screen. Adam is at ABurnNYC. Michael is at MD Kane Jr. John is at John Pisani Photo. Also, be sure to follow Spaceflight Now, simply at Spaceflight Now. You can find us on X, Threads, Blue Sky, and Facebook. In order to not overwhelm our audience with the multitude of fueling milestones for this mission, we're going to go ahead and break apart the countdown timeline into more bite-sized chunks and let you know the milestones sort of in blocks as we go through the timeline, since, as you can see with the L- clock, we've got just about 9 hours on our hands to spread out this wealth of coverage and activities, so let's go ahead and make the hours count. But we'll start with where things have progressed, going from the start of this prop load process, which began with the go, no go pull that was issued. A little bit past the time here on your screen, nominally at L minus 10 hours, 20 minutes, is when the go, no go for tanking typically would happen per the published NASA timeline. Happened a little bit later this morning, but doesn't seem to have adjusted the rest of the T0. So we'll go ahead and progress and let you know the milestones that have just passed and what's coming up next. The process of the Orion cold soak began at L minus 10 hours and 20 minutes. The process of the cold soak was described to us by NASA as a cooling of some of the Orion systems ahead of launch on the day of launch or ahead of the simulated T0 for today's operations. A cold soak lasts about an hour and 20 minutes in duration. At about L minus 10 hours and 10 minutes was when the core stage liquid oxygen and liquid hydrogen transfer lines began their chill down to thermally condition those. You can see it takes a little bit longer for the chill down of the liquid hydrogen lines. We'll go to some sound from Charlie Blackwell Thompson, the Artemis launch director, here in just a little bit about some of the lessons learned from the 4 tanking tests that NASA performed ahead of the launch of the Artemis 1 mission. But, of course, for those of you who recall that mission, there were a number of hydrogen leak issues that cropped up during the tanking tests and during the launch campaigns as well. So they've taken those learnings and factored them into the countdown timeline for Artemis 2. Just about 50 minutes or so ago, the core stage LOX main prop chill began, which lasts about 40 minutes. So right now, where we should be is in the process of core stage liquid hydrogen slow fill start, which lasts roughly 25 minutes, so should have wrapped up about a minute or so ago. We do know that the hold did lift and the terminal clock did continue to run, picking back up at T-minus 8 hours and 10 minutes. So we're about 20 minutes into the resumption of the T-minus clock. About 10 minutes ago was the start of core stage liquid oxygen slow fill, which should wrap up in the next 5 minutes. Just a couple or so minutes ago was when the core stage liquid hydrogen fast fill began, lasting nearly an hour and a half in duration. Coming up next will be the core stage liquid oxygen fast fill, which will last 2 hours and 45 minutes to go through that process before we get to topping and replenishment a little bit later on in the count. Also getting towards some of the milestones regarding the rocket's upper stage here. At about L minus 8 hours 45 minutes, or about 10 minutes from now, T minus 7 minutes or 7 hours and 35 minutes will be the chill down of the feed lines for the liquid hydrogen side of the Interim Cryogenic Propulsion Stage, or the ICPS. That'll last about 35 minutes to get that fully conditioned. We've also included within this timeline the milestones that involve the crew, but important to note, with this tanking test today, the 4 astronauts for the Artemis 2 mission are still in quarantine in Houston and are not physically present here at the Kennedy Space Center for this tanking operation, but more than likely are keeping close tabs on how their launch vehicle is performing. But were this to be a launch day, at L minus 8 hours and 40 minutes would be when the flight crew, or what we'll abbreviate as FC, moving forward in the count, will be waking up. There will also be a launch status check performed at this point in the count. That will be followed by liquid hydrogen fast fill starting at L-8 hours and 10 minutes, lasting about 45 minutes in duration. Meanwhile, on the core stage at L-7 hours and 40 minutes is when core stage liquid hydrogen topping wraps up or starts to begin. And then it will be in what's called replenish about 10 minutes after that. Essentially what that means is the tank will have reached flight levels and teams will continue to replenish any of the liquid hydrogen that boils off to keep it at those flight levels. Again, this is just a tanking test. The countdown clock will be intentionally halted before they get into the final portion that we would see on flight day. We'll go ahead and pause on the countdown timeline at this point. I think that's enough to be a table setter for now and get us primed up for the next most important milestones ahead of us. For those of you who are watching our live coverage of the Starlink 17-32 mission, I want to let you know that SpaceX has confirmed a successful deployment of the 25 Starlink satellites on board that rocket. Taking a look at our live chat here, want to thank a number of folks for your support today. Want to welcome in new channel members. Let's see, Charlie Parker, Mark Trott, Greg Smith, Jose Renee Lynn, JB Bowman, Brooding Jet, Larry Neese, Arlene Pryor, Taco King, and George Sheplock all joining at the pad leader level. Welcome aboard to all of you. Welcome as well to Tommy Boy 14 joining us with membership at the mission specialist level. And Jose, after joining at the pad leader level, upgrading to the mission specialist level. Thanks as well to Dave S. Shuttle upgrading their membership to the launch director level. Really appreciate that enduring support. And for those of you who are able to support at the high levels of membership, help to keep our entry-level pad leader membership where it is and make it more accessible to a greater number of folks. So really appreciate those of you who are able to chip in that regard to support our live coverage, especially for big coverage days like this, where we not only had a launch coverage from Vandenberg, but have in excess of 9, probably 10 hours of dedicated coverage on the SLS rocket today. It's greatly appreciated. I also want to thank my mother, Mary Robinson, one of our channel members, for a very generous $20 super chat. Thanks, Mom. It says, good morning from California. Good morning from Florida, where it is still quite frigid by Florida standards. Currently right around 48 degrees here at the press site, with a feels like temperature of 43 degrees. Not going to get too much warmer as the afternoon progresses. Looks like we're going to reach a high of 52 before dropping back down into the 40s after the sun goes down and into the upper to middle 30s in the overnight hours. Again, this wet dress rehearsal tanking test has a window opening at 9 p.m. Eastern tonight, so it'll be right about 42 degrees when that simulated T0 first happens, barring a shift here in the countdown timeline. One of the constraints to the fueling operations for wet dress as well as for launch is that the average temperature at the pad needs to be at or above 41 degrees for 24 hours. So as teams were assessing the opportunities for tanking over the weekend, they opted to push that back 48 hours to where we are today, with the fueling of the SLS rocket scheduled for right now. Also happening today, not too far away from the press site here, cabinet level official arriving here on the Space Coast, the Secretary of Defense, or the Secretary of War, Pete Hegseth, is taking a tour of Blue Origin's facilities just outside the main gates of the Kennedy Space Center. Greeted upon arrival by Blue Origin founder Jeff Bezos alongside CEO Dave Limp. Expected to give some remarks this afternoon as part of his Arsenal of Freedom tour. That's why he's in town. Also, it's understanding he is or will be visiting NASA facilities here at KSC, in addition to his stop at Blue Origin. Time now currently L minus 8 hours, 46 minutes, 45 seconds and counting. At this point in the count, the core stage fast fill on both the liquid hydrogen and liquid oxygen sides should be underway. And coming up in about a minute and a half is when the chill down of the liquid hydrogen lines on the Interim Cryogenic Propulsion Stage should be beginning as well. Time now L minus 8 hours, 41 minutes, 55 seconds and counting. we should be a few minutes into the ICPS LH2 chill down. Fast fill of the liquid hydrogen on the rocket's upper stage is expected to begin in about half an hour from now. Speaking of hydrogen, that was one of the stickier bits of the learnings from fueling this rocket during the previous wet dress rehearsal tanking tests on the Artemis 1 launch campaign. Want to go to some tape now from Charlie Blackwell Thompson, the Artemis launch director, who discussed some of those lessons learned from the Artemis 1 mission and how those have been applied here to Artemis 2 in the hopes that they can have a smoother WDR and progress towards naming a launch date on the other side.
You know, one of the things that we learned and we worked our way through was, first off, it was a brand new vehicle. And so, as you know, we had some challenges through the wet dress, first with the LOX loading and making sure that we had the loading CONOPS that we started with and the one that we ended up with were slightly different, right? And that had to do with the fact that we were using some amount of legacy hardware. And we found that as we regulated the LOX pump, as an example, in our first two wet dresses, that if you think about having a single stage and an upper stage, and you have that piping that goes up the tower, as you regulated that pump and it slowed down, you would get some warm LOX that would fall into that fill stream of the core stage. And so we had some trouble getting to the right inlet temperatures there. Took us a couple of tries to figure that out. Then during wet dress 3, we had some issues with some hydrogen leaks, right? Hydrogen leaks. So we worked our way through that. We made some modifications to our ground plates. We changed our the way in which we loaded hydrogen, and we got through our wet dress campaign, and then we had a issue with the replenish valve on the launch attempt number 3, where we finally launched, right? We sent a red crew out to the pad and we worked our way through that. So if I were to kind of step back from that and say, what's that biggest lesson that you learned? Well, the first one is on the LOX side of things, we learned how to load. We learned how to change our CONOPS for that. We're utilizing the same CONOPS. Once we made those changes and we worked our way through launch countdown attempt number 1, and number 3, we used that same philosophy and CONOPS for Artemis 1. It worked successfully, and that's what we plan to use again. So that was a big lesson learned. The other lesson learned on the hydrogen side of things, we made some changes to that interface between the flight plate and the ground plate. We made some changes during our Artemis 1 campaign to improve that so that we did not have leaks where you have the flex hoses and the connections on the back of the plate. We saw very good performance during the launch countdown number 3 for that. The interface between what we call the cavity, where those plates come together, we saw some hydrogen leaks there. We learned that the way in which we loaded and the flow rates, the temperatures, the pressures have a whole lot to do with the leakage that we saw within the cavity. And so we modified that, and we were able to manage that through launch countdown number 3. We had the issue with the replenish valve. We went and we made a modification post Artemis 1 to that valve, and we tested it with cryos for the replenish time frame with as many cycles as we would expect to have during Artemis 2. So why do we think that we'll be successful in Artemis 2? It's the lessons that we learned, right? Artemis 1 was a test flight, and we learned a lot during that campaign getting to launch. And the things that we learned relative to how to go load this vehicle, how to load LOX, how to load hydrogen, have all been rolled in to the way in which we intend to load the Artemis 2 vehicle. Now, what's new, right, for Artemis 2? Well, Orion's got some new systems on board. They've got a new ECLS system. We've got the crew interface piece of this, and we have tested those things offline to ensure that, you know, they're not influenced by the cryogenic environment of tanking, but they are used in day of launch, and they have to be used in accordance with our launch countdown and that critical timing. And so we've gone through and we've done a countdown demonstration test. We did a suited crew test before we even got to the VAB. And so we've taken this incremental approach to the testing for the new systems. And so I believe that we'll be ready for wet dress. Again, we'll see. This is our second hardware build for the core stage. So, we'll see how it performs. We don't have the benefit of a green run, but we believe all of the lessons that we've learned from Artemis 1, we have used that countdown and that philosophy as our building blocks for Artemis 2.
Local time here in Florida is just past the bottom of the hour, about 12:31 p.m. Eastern, 17:31 UTC for those joining around the world. The latest update from NASA is that at 12:25, so about 6 minutes ago, the core stage liquid hydrogen and liquid oxygen slow fill were both underway. According to the original published timeline, though, the core stage liquid hydrogen slow fill was expected to start at L-9 hours and 25 minutes and slow fill on the LOX tank on the core stage at L-9 hours and 10 minutes. We're trying to work out and get some clarification from NASA if the published times that are being shared as far as the updates directly from them indicate that the T0, the first T0 has shifted to the right a little bit. Actually, stand by. Time currently L-8 hours, 25 minutes, 16 seconds and counting. Right now, this L- clock is counting down to the opening of the testing window at 9 p.m. tonight Eastern Time. Again, we're working to get some clarity on if the updates coming from NASA's tech feed correspond with where things have shifted to in the flow of things. For example, they noted at 12:31 p.m. Eastern, so about 4 minutes ago, core stage liquid hydrogen fast fill got underway. You can actually start to see some of those signs of fueling if you look underneath the mobile launcher platform there. You can see some vapor peaking down beneath the 4 RS-25 engines. So a good visual indication that, yes, in fact, fueling has been underway on the SLS rocket. Core stage liquid hydrogen fast fill on the published timeline was scheduled to begin at L-9 hours. So against what we're seeing on the big clock out here, that would have been about a little more than half an hour or so ago. Again, taking a look at our live chat to address a super chat question from K2 Hat. First off, K2, thanks for the previous $2 super chat saying cold in Miko, Florida this morning. Thanks for the coverage. Well, thank you for your support of the coverage. And then to your second message asking what is a green run, which was referenced by Artemis launch director Charlie Blackwell Thompson in the clip that we played for you. The green run was a series of tests and checkouts culminating in a full duration static fire testing of the core stage of the SLS rocket that was performed at the Stennis Space Center in Mississippi in the lead up to the Artemis 1 launch. Latest from NASA, 12:36 p.m. Eastern, core stage, liquid hydrogen, liquid oxygen fast fill underway. As things are currently planned, there will not be a green run test for the SLS rocket's core stages for the foreseeable future of the program. However, a green run is planned for a new piece of hardware that is set to start flying on the Artemis 4 mission, and that is the exploration upper stage. I mentioned some of the prop load for the ICPS, or the Interim Cryogenic Propulsion Stage. That's manufactured by United Launch Alliance in concert with Boeing, and it's powered by a single RL-10 engine. Meanwhile, the exploration upper stage will be powered by 4 RL-10 engines and is a notably larger upper stage than the ICPS. And that's why NASA has been, well, their contractor Bechtel has been building the larger Mobile Launcher 2, which is currently sitting adjacent to the Vehicle Assembly Building here at the Kennedy Space Center. That will account for the larger exploration upper stage, meaning that the position of the crew access arm has to be higher up on the tower in addition to the umbilicals that will go to the EUS. Once that's ready for its green run, it'll be brought to Stennis and put through similar paces for that fueling and testing operation before it would be shipped out here to the Kennedy Space Center on the Pegasus barge. Local time here, 12:42 p.m. Eastern, 17:42 UTC for those joining around the world. As I mentioned, the latest update from NASA is that the core stage liquid hydrogen and liquid oxygen fast fill are underway. For the liquid hydrogen side of the core stage, that tank will take about an hour and 20 minutes to complete the fast fill phase of tanking. Core stage hydrogen tank has a capacity of 537,000 gallons, or roughly 2 million liters. Meanwhile, on the liquid oxygen side, with it being in fast fill as well, that process will take 2 hours and 45 minutes in total, assuming a nominal fill time. The LOX tank on the core stage holds 196,000 gallons, or 741,941 liters. LOX is kept to a temperature of negative 297 degrees Fahrenheit, or 183 degrees Celsius. Additional gaseous oxygen is vented overboard. Seen some of that venting just underneath the mobile launcher platform. To give you a sense of scale, the liquid hydrogen tank is 27.6 feet, or 8.41 meters in diameter. It's about 130 feet, or 39.6 meters from tip to tip. The hydrogen tank is made up of 5 welded barrel sections, each roughly 22 feet or 6.7 meters in height, and has 2 end domes. Meanwhile, the LOX tank is also 27.6 feet, 8.41 meters in diameter, notably shorter at 51 feet or 16 meters in length or height, depending on how you want to think about it. It's made up of 2 15.6 foot or 4.75 meter barrel sections. Those are made up of an isogrid aluminum panels alongside the 2 domes. Time to the opening of the test window is 8 hours, 12 minutes, and 40 seconds. Just about 13 minutes till the top of the hour here. In addition to the teams here at the Kennedy Space Center, as well as the other supporting NASA centers, that are tied in with this wet dress rehearsal tanking test. There are also the folks over at what's called the Eastern Range, managed by the folks at the United States Space Force Space Launch Delta 45. This past week over in Orlando was the conference in the middle of Commercial Space Week called the Space Mobility Conference, which is geared towards items of conversation and panels centered around the defense space. On the sidelines of that, we had the opportunity to talk one-on-one with some of the leadership over at SLD 45 and learn a little bit more about what the process is for the Space Force supporting NASA's Artemis program, talking about the WDR and eventually getting ready for launch. So I want to go to part of that conversation right now. Where in this clip, we'll start by hearing from Colonel Joyce Bolson, who's the deputy commander of SLD 45, about the Space Force's role in making sure that the Artemis program goes off without a hitch.
Our role from a wet dress rehearsal perspective is to totally support NASA as they test out the vehicle and make sure it's ready to go for launch. So we will be on console for about 11 to 13 hours. We come on a number of hours, 7-ish, before the actual T0 time, and then we're planning to be on console for another 3 to 4 hours after that. So we are definitely in a support mode from a wet dress rehearsal perspective. We are responsible for giving NASA the data that they need to make sure that the vehicle is performing as expected, as well as public safety. So that is different than mission assurance. That is actually different than the safety of the astronauts. There are plans in place for that. The vehicle is developed with the astronaut safety in mind, but our responsibility from a launch decision authority is making sure that public safety is ensured with any launch.
local time just past the top of the hour. In the latest update from NASA, the chill down of the liquid hydrogen feed lines began at 12:56 p.m. Eastern, so just about 5 minutes ago, and that ICPS LH2 chill lasts about 35 minutes in duration. Again, because this is a wet dress rehearsal tanking test, emphasis on the test part of all this, the timing of things won't be as precise or as exact as, say, like with a Falcon 9 rocket launch, where as the milestones come up, if they don't happen on time and in sequence, that would be a showstopper. Things are a little bit different here with the SLS rocket. If the astronauts were in the loop on today's, let me rephrase. If this were a launch attempt today instead of a wet dress rehearsal, at this point in the count, the flight crew would be waking up and getting a status check. Based off of how the timeline has evolved since the beginning of things, we should get our next big update here around the bottom of the hour, so about 1:30 here local time. 18:30 UTC for those around the world. That's when the ICPS liquid hydrogen fast fill should start, lasting 45 minutes in duration. just about 7 minutes now past the top of the hour here on the East Coast. Following today's wet dress rehearsal tanking test, NASA has announced there will be an early results press conference scheduled for noontime, 12 p.m. Eastern, 1700 UTC for those around the world, on tomorrow, Tuesday, February 3rd. During that briefing, we should be hearing from NASA's Associate Administrator, Amit Kshatriya, Lori Glaze, the Acting Associate Administrator for the Exploration Systems Development Mission Directorate, John Honeycutt, the Chair of the Artemis II Mission Management Team, as well as a yet-to-be-named representative of the Exploration Ground Systems Program. It is after the wet dress rehearsal is completed and teams go into a flight readiness review, they will determine if, in fact, they are ready to proceed towards scheduling a launch date for the Artemis II mission. After wet dress, they will also decide if they're going to be bringing the Artemis II astronauts here to the Kennedy Space Center. That crew have been in quarantine since January 21st. And depending on the readiness of the rocket, NASA that is, can either extend the crew's time in quarantine if it looks like a launch is still forthcoming in the time where a quarantine would need to be preserved, or the crew can be allowed to exit quarantine if the launch is pushing further into the future. Again, a launch date won't be determined until after we get through today's wet dress rehearsal tanking test and teams are able to review the data. If the crews are going to be making their way here to the Sunshine State, they will be flying on their T-38 jets, landing at the former shuttle landing facility, now managed by Space Florida, renamed to the Launch and Landing Facility. They're set to arrive around 3 p.m. on Tuesday, February 3rd, at around 3 p.m. Eastern Time. Like with any typical crew arrival, there will be a gaggle with members of the press scheduled for shortly after touchdown, and they're greeted by NASA leadership. We will, of course, be bringing you live coverage of crew arrival if it gets to that point tomorrow. We'll have the briefing for you as well live. We will put that briefing into our 24/7 live stream called Artemis Live. So that'll continue to be your one-stop shop for 24/7 views of the rocket, as well as those relevant updates on the program. a bit of a sidebar to the wet dress rehearsal tanking test, but for those who are in town and we're hoping to catch the flight of a Falcon 9 rocket tomorrow, that launch from Space Launch Complex 40, Starlink Mission 6-103, that has been delayed. That Falcon 9 now set to lift off during a window that opens up at 4:46 p.m. Eastern on February 4th. We will, of course, have live coverage of that mission when it happens, but just wanted to make folks aware that the timeline for that has changed if you were planning on making that a part of your time here to cover or to view the flight of Artemis 2. As the combination of the Cape and Cape Canaveral Space Force Station, to be more specific, and the Kennedy Space Center combined make for the busiest spaceport in the world at the moment. Life continues to go on here as NASA's march towards Artemis 2 continues. And that, of course, does mean, like I just mentioned, upcoming flights for instance, the Falcon 9 rocket from Pad 40. I want to go back to some more tape now from our conversation with the leadership at Space Launch Delta 45. In this part of the conversation, we talk about how the logistics work with managing flights from other pads, in addition to the resources that need to be dedicated to supporting NASA's Artemis 2 launch. So we'll start our conversation once again with Colonel Joyce Bolson.
Some of our launches, ones that require FTS still, or are even relatively new and are still maturing a little bit, so even our Vulcan launches, our New Glenn launches, those still tend to use more resources, more range resources. Some of them, depending on how they have established their commodities relationships, are dependent on that KSC pipeline that is provided from a commercial contractor for GN2, but that is a business choice that they have made. From a SpaceX and Falcon 9 launch from Launch Complex 40, that launch complex is almost completely independent from anything related to NASA. So it is possible to see a Falcon 9 Starlink launch that doesn't require a huge number of range assets and doesn't require commodities from NASA to be able to go. Again, priority is the Artemis launch. We understand that priority from a national perspective, but it is possible to launch both of those, and so the team will work to see what's possible.
Well, if I could expand that out briefly, the dynamic range scheduling that our Range Operations Squadron brings to the game takes a look at all range operations, whether it's an Artemis launch, a Navy test launch, a ULA, a Blue Origin, a Relativity, a SpaceX launch. In partnership with those launch service providers coming in to talk what range operations looks like, is where we deconflict those operations. Every launch service provider has a dedicated program support manager in our Range Operations Squadron that works day to day with that launch service provider to identify what the needs are that LSP needs to be able to facilitate that launch option or that launch opportunity. We bring those into a weekly scheduling meeting. I mentioned there on the panel that once a week at the Cape, we bring all the launch service providers and government entities together to work that real-time deconfliction. The tight partnership and collaboration that we have on the Space Coast exceeds anything I have seen in my entire career. the LSPs coming together to work together, the commodity providers coming together to see a successful launch, KSC, the FAA, the Army, the Navy, the Space Force, all sitting around the table to talk what opportunities are there to be able to support getting mass or humans to orbit.
And speaking of getting humans to orbit in the complicated scheduling of flights here at the Kennedy Space Center and Cape Canaveral Space Force Station, NASA and SpaceX are also marching towards the launch of the Crew 12 flight to the International Space Station, led by NASA astronaut Jessica Meir. The 3 astronauts and 1 cosmonaut from Roscosmos will fly up to the orbiting outpost for a scheduled 8-month stay in low Earth orbit. A number of things need to be deconflicted to allow both of these missions to move forward, which if you go back to one of our previous posts on X, we have a thread up talking about the deconfliction work that teams have been performing to make sure that both Artemis 2 and Crew 12 can launch successfully. The long and short of it, though, is right now the preference and the precedence at the range is for Artemis 2. So essentially, if Artemis 2 launches, then Crew 12 will remain on the ground until about 11 days after liftoff, or after splash. Yes, 11 days after liftoff. So about a day or so after splashdown would be the earliest that Crew 12 would launch from Space Launch Complex 40 at Cape Canaveral Space Force Station. Things get a little bit more particular when you talk about if NASA were to attempt to launch Artemis 2 and then had to scrub. If they were able to try again within the February window, that would change things as far as the timing for Crew 12. And if NASA tries to launch but then doesn't, then that presents some early opportunities for Crew 12 in the middle of the month. But after this wet dress rehearsal, if NASA ultimately decides that they just aren't able to attempt a launch within the February window at all, then that would present an opportunity for Crew 12 to launch as early as February 11th, at the very earliest at this point. Some of the items that need to happen before that, of course, are moving the Dragon spacecraft named Freedom out to the hangar at Slick 40 and doing those final pieces of processing out there, and of course integration with the Falcon 9 rocket, roll out to the pad. Dry dress rehearsal and a static fire test are also on order for the first stage booster with the tail number 1101. This will be its second flight in support of the Crew 12 mission when that launch does happen. So essentially the fate of the Artemis 2 mission needs to be determined with a little bit more specificity before we can say with certainty when Crew 12 will be launching to the International Space Station. But of course we will have our typical robust live launch coverage for that crewed flight to orbit as well. Latest update from NASA on the process for the wet dress rehearsal tanking test came at about 1:09 p.m. Eastern, 1809 UTC for those around the world. That was the start of the ICPS, the Interim Cryogenic Propulsion Stage hydrogen fast fill. This fast filling process on the upper stage hydrogen tank expected to last roughly 45 minutes in duration. The next big milestones will be coming up regarding the core stage liquid hydrogen tank, assuming all is continuing to go well on hydrogen loading. That should reach the topping phase of its fill in about, let's see, do a little mental math here since the timeline is adjusted versus what's on the L minus clock, so bear with me here for a second. Okay, core stage LH2 topping should be beginning in about 10 minutes. The topping process itself will last 10 minutes, and then the core stage liquid hydrogen tank will be in that replenish mode until the end of the wet dress rehearsal test today. Local time now, about 1:36 p.m. Eastern, 1836 UTC. As the fast fill process continues on with the Interim Cryogenic Propulsion Stage, and core stage LH2 topping is still out ahead of us. Some of these zoomed in views, you can still see a little bit of venting there from the 4 RS-25 engines coming from just underneath the base of the ML platform. Yesterday, as the full moon was just about at its peak, NASA gave the opportunity for some photographers, including our photographers here, John and Adam, the ability to go out and capture some moonrise views with the Space Launch System rocket in frame. So want to share one of those clips with you right now. You can head on over to our social media, specifically X, where we've got a few more of those up right now. But here's a view of the snow moon as captured by John Pisani last night. And again, if you'd like to see the time lapse with the full moonrise in there, we've got that up on our X account, formerly Twitter. Local time now, 1:42 p.m. Eastern, 1842 UTC. About 10 minutes ago, NASA shared an update, quote, core stage liquid hydrogen flow stopped for troubleshooting. Liquid oxygen flow continues. We'll be sure to continue to monitor this. Of course, the liquid hydrogen side of the operation did provide NASA quite a bit of trouble and a lot of troubleshooting throughout the course of the 4 wet dress rehearsal tanking tests during the Artemis 1 launch campaign. Again, as of 1:32 p.m. Eastern, NASA confirmed that core stage liquid hydrogen flow has stopped for, quote, troubleshooting. Local time now, just about 1:50 here on the East Coast, 1850 UTC. Want to read the more full statement from NASA about the reason for the core stage liquid hydrogen flow stoppage. They say, and I quote, "Teams have stopped the flow of liquid hydrogen through the tail service mast umbilical interface into the core stage after leak concentrations exceeded allowable limits. Stopping the flow allows engineers to perform troubleshooting procedures that were developed after Artemis 1. Liquid oxygen continues to flow into the core stage, and liquid hydrogen continues to flow into the upper stage." When we played the clip from Artemis launch director Charlie Blackwell Thompson earlier in the broadcast, she did mention that this was one of the learnings coming out of the campaign from Artemis 1. Back during the mission overview briefings at the Johnson Space Center this past September, we also asked about any expected showstoppers for the wet dress rehearsal, and at the time, Charlie Blackwell Thompson also mentioned that they had learned from the WDRs from Artemis 1 and had plans in place to manage and mitigate them that would allow them to continue to progress through the wet dress rehearsal. So hopefully this won't be any kind of showstopper for the tanking test today, and that teams will be able to get this sorted out and continue to load liquid hydrogen once again onto the core stage of the Space Launch System rocket. Getting close to the top of the hour here, the tech feed from NASA is now introducing a nifty fueling percentage graphic to show the progress on the various liquid oxygen and liquid hydrogen tanks on both the core stage and the Interim Cryogenic Propulsion Stage. You can see when they stopped the flow of LH2 on the core stage, they were a little bit more than halfway through loading that up and going through what's called the fast fill. Liquid hydrogen loading also liquid oxygen loading about halfway completed on the core stage at this juncture. Not quite a quarter of the LH2 tank on the Interim Cryogenic Propulsion Stage has been loaded, and LOX load on the upper stage has not begun. just a little bit past the top of the hour here on the East Coast, about 2:02 p.m. Eastern, 19:02 UTC. In addition to these more ground level views of the Space Launch System rocket that we are sharing with you live as the wet dress rehearsal tanking test continues, there have been some interesting aerial captures from a couple of notable vantage points. One of those includes a flyover from a couple of jets owned by NASA Administrator Jared Isaacman, as he gave the Secretary of Defense a tour of Cape Canaveral and the Kennedy Space Center before the Secretary gave some remarks over at Blue Origin's rocket park complex. In addition to this view, though, we have a really nice view from just a little bit higher up. These photos were captured by NASA astronaut, the lone NASA astronaut that's currently on board the International Space Station, Chris Williams, who's holding down the fort alongside the two Sergeys of Roscosmos ahead of the arrival of Crew 12 later this month. Williams says he used a 16,000 millimeter lens set up in the Window Observational Research Facility to get a few of those photos that you see here on your screen, showing on the one on the left a nice center shot of Launch Complex 39B, and of course the one that's a little bit more zoomed out, pads 39A and B. You can actually technically see us here at the press site if you look at the bottom left-hand corner of the longer photo. The press site lawn is in the lower left-hand side of the larger body of water, the turn basin. You can see the vehicle assembly building casting a very long shadow in this photo as the ISS passed over the Sunshine State. If the Artemis 2 mission launches before Crew 12, Chris Williams may be the only American to have the opportunity to see the Artemis 2 launch from the vantage point of low Earth orbit. Latest update from NASA is that the ICPS liquid oxygen chill down of the feed lines is underway. And the troubleshooting regarding liquid hydrogen on the core stage is still ongoing. The ICPS LOX chill should last about 10 minutes or so. I haven't seen the fill graphics here in a minute, but the core stage liquid oxygen tank should also be in topping mode right about now. It would also be around this time that the Ryan communications system would be activated, again, if the crew were in the loop. Local time now 2:12 p.m. Eastern, 1912 UTC. If you take a look near the top of the Interim Cryogenic Propulsion Stage at the near the top of the core stage, I should say, just beneath the launch vehicle stage adapter, you can see a little bit of venting near that checker, the white and black in the center of the vehicle. If you look just to the right of that, you can see some of that off-gassing there, that venting. This venting that we're seeing here, we believe to be the ICPS liquid hydrogen vent and relief test, which is scheduled to last for about 20 minutes in duration. Local time 2:18 p.m. Eastern, 1918 UTC for those joining around the world. The venting that we're seeing, it's a little bit hard to gauge exactly when this began, but it should last roughly 20 minutes in duration. So if we've got the ballpark of the timeline correct, this vent should wrap up in the next minute and a half to 2 minutes or so. Once that's done, the process of ICPS LH2 tank topping will start, and that'll last about 10 minutes. And then at that point, the upper stage liquid hydrogen tank should be in replenish. So we'll wait to see when we stop seeing this vent here. And that'll give us a decent indication of where we are in the fueling progress, at least on the upper stage. Again, because NASA is not providing live commentary in a tech feed capacity and is instead posting updates via its online blog, we're left to put some of these pieces together ourselves based off of the information we know about the rocket and the fueling timeline for this tanking test as laid out prior to its beginning. Local time now, 2:41 p.m. Eastern, 1941 UTC. The last update that we got from NASA was back referring to events as of 1:59 p.m. So more than 40 minutes ago was the last official word from NASA on the status of the tanking operations beyond the showing of the graphic briefly that showed the percentage filled. Local time now just past the top of the hour, 3:01 p.m. Eastern, 20:01 UTC for those joining around the world. As you're seeing with the fueling graphic on your screen, teams seem to have picked things back up again with the loading of liquid hydrogen on board the core stage of the SLS rocket. Also loading of LH2 on the rocket's upper stage, the ICPS, reaching and exceeding 20%, so that is also moving once again. As you can see with the crawl, this big box right now coming from NASA's tech feed, there hasn't been a text update from the agency for now more than an hour. Also, no update to the NASA blog providing details or any additional information on the troubleshooting that was performed for addressing the concerns regarding to LH2 on the core stage. Again, the way that NASA described this back, let's see, this was back at about 1:42 p.m., so about 75 minutes ago. They said, quote, teams have stopped the flow of liquid hydrogen through the tail service mast umbilical interface into the core stage after leak concentrations exceeded allowable limits. Stopping the flow allows engineers to perform troubleshooting procedures that were developed after Artemis 1. And of course adding, quote, liquid oxygen continues to flow onto the core stage and liquid hydrogen continues to flow onto the upper stage, though it did appear for some time as though liquid hydrogen flow was stopped on the upper stage. That was the most color that we've gotten regarding, again, what they called the issue with the tail service mast umbilical having a reached, quote, leak concentrations that exceeded allowable limits. We've reached out to NASA to inquire into where things stand on the timeline, especially regarding the ICPS, if that was paused as well as teams were addressing the core stage LH2. Waiting to hear back. It's just about quarter past the hour here on the East Coast, 3:14 p.m. Eastern, 2014 UTC. It has now been more than an hour since NASA's last update regarding the status of the wet dress rehearsal tanking test. The agency has not updated what's referred to as a crawl or a ticker on its tech feed since the update at 1:59 p.m., noting that at that stage, the Interim Cryogenic Propulsion Stage liquid oxygen feed lines were undergoing the chill down ahead of upper stage LOX load, and that they were still troubleshooting the issue with the umbilical for the core stage liquid hydrogen. The blog, which NASA mentioned would include additional timely updates throughout the course of the tanking, has also, again, not been updated since now a little more than an hour ago. So it's that combined with the fact that the go for the start of prop load was given later than would sync with the L- clock, leading to a T0 at 9 p.m. makes it fairly difficult to know with great certainty exactly where we are in the count. We've got a rough estimate, but trying to give you as good of information as possible and not overshoot where NASA is, since we don't have clear and consistently updating real-time insight, unfortunately. Local time now, 3:23 p.m. Eastern, 2023 UTC. We do finally now have another update from NASA, this corresponding to 3:08 p.m. Eastern, 2008 UTC. That update, though, appeared within the last couple of minutes. They say, quote, core stage liquid hydrogen troubleshooting resumed after temporary return to fast fill. Don't have much more to provide than that. Actually, let's see. Yeah, nothing new, unfortunately, on the Artemis blog. But understanding this update as best we can, it sounds like, as we saw with the fueling graphics, there was an attempt to, well, not an attempt, they did resume fast fill of liquid hydrogen on the rocket's core stage, and it's unclear if they've since stopped fast fill, but they have resumed troubleshooting the issue. So presumably fast fill would have also wrapped up, at least temporarily, so that that troubleshooting could progress. Could be that NASA has stepped back into the fast fill, at least for a little bit, to get more data on the leak issue. Local time 3:27 p.m. Eastern, 2027 UTC. Here's the latest statement from NASA on the state of affairs with the wet dress rehearsal. They said, and I quote, after teams temporarily resumed fast fill of liquid hydrogen operations into the core stage, initial steps to correct the leak proved unsuccessful. The leak rate at the interface of the tail service mast umbilical continues to exceed the allowable limits. Liquid hydrogen filling operations on both the core stage and upper stage are paused as teams meet to determine the next steps, end quote. So this does appear to validate what appeared to be the issue, or what appeared to be the case back when we were seeing some of the earlier graphics regarding the various propellant tank fueling levels, noting that when things were paused on the core stage hydrogen, things were also paused on the ICPS hydrogen tank as well, while liquid oxygen was continuing to flow in fast fill at that point on the core stage. So far as we know, and it hasn't been mentioned in some time, but one would assume that at this point NASA has not started loading liquid oxygen on board the Interim Cryogenic Propulsion Stage just yet. But that also hasn't been explicitly mentioned or ruled out in the most recent updates from NASA either, so a little bit hard to know explicitly whether or not that is the case. Local time now past the bottom of the hour at 3:33 p.m. Eastern, 2033 UTC. The fueling graphic is back up on the screen, as you can see here. Liquid oxygen now has reached flight levels and presumably is in replenish until the end of this test. Liquid oxygen for the core stage, that is. Liquid hydrogen right now at 77% of the total capacity of more than 538,000 gallons, and liquid hydrogen on the Interim Cryogenic Propulsion Stage about a quarter of the way filled. As we noted in the latest statement from NASA, they did say that liquid hydrogen filling operations on both the core stage and the upper stage have been paused as they are determining the next steps after coming to the conclusion that, quote, initial steps to correct the leak proved unsuccessful, end quote. That was regarding the tail service mast umbilical that is leaking at a level that is outside of the allowable limits according to the space agency. While the countdown clock, the L- clock that we can see out here on the press lawn continues to tick down. We know, obviously, since the go for the start of prop load was delayed a little bit, the clock has been out of sync, but in less than an hour now, once the clock reaches L- 4 hours and 40 minutes, that's when the T- clock should hit T- 3 hours and 30 minutes. Now, where things fall, it's in about 45 minutes from now. At that point, that is, according to the published and planned countdown, when the 40-minute hold, a planned 40-minute hold, would come into play. And it's also at that point in which all stages of the SLS rocket should be in replenish. Against this published timeline, where we should be, according to this again, things have shuffled around a fair amount, and that's not terribly surprising given that this is the first fueling test for this. And actually, you can see now the LOX gauge on the ICPS has shown some signs of filling beginning, now at 5%. ICPS liquid oxygen was expected to get into fast fill when the clock hit L- 6 hours, but again, we're a little bit of ways away from where the clocks line up, so it's kind of hard to ballpark exactly where we are with one thing compared to another. Just reviewing the timeline again to make sure that we're passing along the best information possible to you, our dear audience. The way that the timeline was structured for things to flow was such that upper stage liquid hydrogen loading was set to wrap up with the LH2 tank on the ICPS reaching the replenish stage. So, in other words, reaching flight levels and then just staying in that mode of keeping it at that level with the understanding that some of it will naturally boil off, and so you need to add a little bit more to keep it at flight levels. That's what replenish signifies. That the upper stage LH2 tank would be in replenish prior to the start of liquid oxygen load on the rocket's upper stage. So the fact that with that graphic that we just saw showing that the upper stage liquid hydrogen tank is still sitting at just 25% filled when they've started loading liquid oxygen now on the rocket's upper stage, don't want to draw too many conclusions since there are a number of factors that we don't know with any certainty, but it could be that NASA wants to gain as much data as possible about tanking both stages of this rocket and made the determination that they would just proceed into liquid oxygen load on the upper stage while they've paused hydrogen filling on both the core stage and the upper stage. Again, that's a bit of conjecture just based off of the flow of the timeline, if you will, but don't have a lot more than that to go off of right now. Again, we're putting puzzle pieces together right now because the way that NASA determined that it wanted to run the wet dress rehearsal today was without the use of a public affairs officer inside the Launch Control Center who could relay in real time updates to the public on a tech feed, as we had during some of the latter wet dress rehearsal tanking tests during the Artemis 1 campaign. The decision was made to not do that and instead to publish some updates in a crawl form at the bottom of a tech feed. And then in addition to that, to post updates to the Artemis blog on NASA's website. Local time now, 3:48 p.m. Eastern, 20:48 UTC for those joining around the world. The last update coming from NASA, correlating with the update, came from the point in time of 3:08 p.m. Eastern, was shared in the last 10-15 minutes. Actually, let's see. Yep. For those of you just joining us, NASA said, and I quote in its latest update, after teams temporarily resumed fast fill of liquid hydrogen operations into the core stage, initial steps to correct the leak proved unsuccessful. The leak rate at the interface of the tail service mast umbilical continued to exceed the allowable limits. Liquid hydrogen filling operations on both the core stage and upper stage are paused as the team meets to determine next steps, end quote. At this point in the count, we are about 30 minutes away from what would be the nominal end of tanking, when all four fuel tanks, liquid hydrogen and liquid oxygen on both the upper and lower stages, should be hitting their replenish. Here's a look from the campaign into Artemis 1. This is what the tail service mast umbilical looks like. This image was taken during what was referred to as a drop test. This was when it was being worked on in High Bay 3 of the Vehicle Assembly Building back in June of 2019. For scale, the TSMUs are about 35 feet in height and connect to the SLS core stage aft section and provide the liquid oxygen and liquid hydrogen fuel line or fluid lines and electrical cable connections to the core stage engine section. That's in order to flow the propellant during pre-launch operations or pre-fueling operations for the wet dress rehearsal. The drop test is the retraction of the TSMUs, retreating back into the larger protective structure upon liftoff, or just before liftoff. And we do have a new update from NASA coming down at 3:48 p.m. Eastern, 2048 UTC. Core stage liquid hydrogen fast fill has resumed. Seeing if there's any additional details on that. Not seeing a new blog post just yet. With liquid hydrogen fast fill underway. Want to go back for those of you who weren't here early in the broadcast. This may be your first time seeing this piece of tape in our coverage today, but want to play this part of the pre-rollout news briefing, the comments from Artemis launch director Charlie Blackwell Thompson regarding the lessons learned from the various tankings needed during the Artemis 1 campaign and how they've been rolled into the Artemis 2 launch campaign this go around.
You know, one of the things that we learned and we worked our way through was, first off, it was a brand new vehicle. And so, as you know, we had some challenges through the wet dress, first with the LOX loading and making sure that we had the loading CONOPS that we started with and the one that we ended up with were slightly different, right? And that had to do with the fact that we were using some amount of legacy hardware, and we found that as we regulated the LOX pump, as an example, in our first two wet dresses, that if you think about having a single stage and an upper stage, and you have that piping that goes up the tower, as you regulated that pump and it slowed down, you would get some warm LOX that would fall into that fill stream of the core stage. And so we had some trouble getting to the right inlet temperatures there. Took us a couple of tries to figure that out. Then during wet dress 3, we had some issues with some hydrogen leaks, right? Hydrogen leaks. So we worked our way through that. We made some modifications to our ground plates. We changed our the way in which we loaded hydrogen, and we got through our wet dress campaign, and then we had a issue with the replenish valve on the launch attempt number 3. Where we finally launched, right? We sent a red crew out to the pad and we worked our way through that. So if I were to kind of step back from that and say, what's that biggest lesson that you learned? Well, the first one is on the LOX side of things, we learned how to load. We learned how to change our CONOPS for that. We're utilizing the same CONOPS. Once we made those changes and we worked our way through launch countdown attempt number 1, and number 3, we used that same philosophy and CONOPS for Artemis 1. It worked successfully, and that's what we plan to use again. So that was a big lesson learned. The other lesson learned on the hydrogen side of things, we made some changes to that interface between the flight plate and the ground plate. We made some changes during our Artemis 1 campaign to improve that so that we did not have leaks where you have the flex hoses and the connections on the back of the plate. We saw very good performance during the launch countdown number 3 for that. The interface between what we call the cavity, where those plates come together, we saw some hydrogen leaks there. We learned that the way in which we loaded and the flow rates, the temperatures, the pressures have a whole lot to do with the leakage that we saw within the cavity. And so we modified that, and we were able to manage that through launch countdown number 3. We had the issue with the replenish valve. We went and we made a modification post Artemis 1 to that valve, and we tested it with cryos for the replenish time frame. with as many cycles as we would expect to have during Artemis 2. So, so why do we think that we'll be successful in Artemis 2? It's the lessons that we learned, right? Artemis 1 was a test flight, and we learned a lot during that campaign getting to launch. And the things that we learned relative to how to go load this vehicle, how to load LOX, how to load hydrogen, have all been rolled in to the way in which we intend to load the Artemis 2 vehicle. Now, what's new, right, for Artemis 2? Well, Orion's got some new systems on board. They've got a new ECLS system. We've got the crew interface piece of this, and we have tested those things offline to ensure that, you know, they're not influenced by the cryogenic environment of tanking, but they are used in day of launch, and they have to be used in accordance with our launch countdown and that critical timing. And so we've gone through and we've done a countdown demonstration test. We did a suited crew test before we even got to the VAB. And so we've taken this incremental approach to the testing for the new systems. And so I believe that we'll be ready for wet dress. Again, we'll see. This is our second hardware build for the core stage, so you know we'll see how it performs. We don't have the benefit of a green run, and so but we believe all of the lessons that we've learned from Artemis 1, we have used that countdown and that philosophy as our building blocks for Artemis 2.
Local time now at the top of the hour, 4 p.m. Eastern, 2100 UTC for those joining around the world. If you are just checking in with us live, you're watching Spaceflight Now's live coverage of the Artemis 2 wet dress rehearsal, an important tanking test for the 322-foot tall rocket that will help NASA determine if they are able to set a launch date during the February window, or if they need more time to ready the vehicle. That will take NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, along with Canadian Space Agency astronaut Jeremy Hansen, on a roughly 10-day trip around the moon and back, with a splashdown planned off the coast of California. In the latest update from the agency, they note as of 3:50 p.m. Eastern that the Interim Cryogenic Propulsion Stage liquid oxygen fast fill is now underway, and that fast fill on the core stage liquid hydrogen has also resumed. There's a new statement that expands upon that sort of headline, if you will, which I'll read in full. Quote, ground teams have resumed the fast fill of liquid hydrogen operations into the core stage of the SLS, Space Launch System, rocket. Operations were stopped twice after leak rates at the interface of the tail service mast umbilical exceeded allowable limits. Engineers will attempt to complete fast fill and begin topping off the tank. Should that be successful, they will attempt to manage the hydrogen concentration, keeping it within acceptable limits during core stage hydrogen loading. Once the tank is full, the rocket will go into a replenish phase, in which the flow rates are reduced. This is expected to help control the liquid hydrogen concentration level in the umbilical. Teams are reinitiating liquid oxygen flow into the upper stage. End quote. Meanwhile, as we get into the late afternoon hours, about 40 or so minutes ago, we did hear a loudspeaker announcement here at the KSC press site noting that temperatures less than or equal to 40 degrees will kick into effect beginning around 7 p.m. Eastern tonight, quad 0 UTC, and that will last until 9 a.m. tomorrow. That's 1400 UTC on January 3rd. So for those of us here at the KSC press site monitoring the progress of the WDR, it is going to continue to get colder as the evening progresses here. We'll see if that bears any impact on the tanking operations, though. Given the fact that they've decided to step into the fueling campaign, it hopefully will not be a hindrance to the tanking operation. local time now, 4:17 p.m. Eastern, 21:17 UTC. If you look at the rocket just about at the point where the launch vehicle stage adapter, which is the sort of conical part of at the top of the core stage. Oh, we see a NASA helicopter going by in the background. Actually, just above where that NASA chopper was flying, a little bit higher than that, we are seeing start of a new vent here. Unclear if this is the ICPS LOX vent and relief test, which per the original timeline was supposed to last around 15 or so minutes. The venting I was pointing out is where the launch vehicle stage adapter meets what's called the Orion stage adapter, or more simply, where the orange meets the white. As you can see with the clock on the screen, L minus 4 hours, 41 minutes and counting. At this point, we are less than a minute away from the point of the countdown where going to the original T0 of 9 p.m. tonight. This is where the start of the 40-minute planned hold is expected to begin once that clock reaches L minus 4 hours and 40 minutes. It's at this point, per the original timeline, where the rocket should be fully in replenish. Given the delays to the liquid hydrogen loading, though, that will most certainly not be the case, more than likely. And the start of the 40-minute hold is now upon us for the original timeline. This was one of a series of holds that was built into the Artemis 2 countdown timeline. Clock stopped on the T-minus clock at T-minus 3 hours and 30 minutes. A number of events are scheduled to, again, per the original timeline, were scheduled to happen in this slot. The ICPS liquid oxygen set to hit replenish at that time. That's marking when all stages go into replenish. At this point in the count, the closeout crew is also... There goes the chopper. The closeout crew is also set to depart to the White Room. If the crew were involved in the mission today, the flight crew would be, at this stage, leaving the Neil Armstrong Operations and Checkout suit-up room. They would spend about 10 minutes outside after coming down the elevator and greeting their friends and family before hopping into the crew transport vehicle, which originally the crew transport vehicle for the Artemis 2 mission was set to be a series of 3 electric vehicles provided by a company called Canoe Technologies. However, they went bankrupt last year, and so instead NASA decided to lease the Astrovan that Boeing uses for transporting its crew for Starliner missions out to Space Launch Complex 41. It has been rewrapped for the Artemis mission and will be used for this campaign until launch. Some of the other events that will happen or that are scheduled to happen inside this 40-minute hold: the flight crew departs to LC-39B at nominally L-4 hours and 30 minutes. The preparations for the flight crew to ingress into the Orion spacecraft happen at L-4 hours and 25 minutes. The flight crew heads into the White Room about 5 minutes after that, and then by L-4 hours and 10 minutes, the crew puts on their helmets and gloves, and once the hold releases at L-4 hours, that's when the flight crew is in the process of doing their ingress, as well as conducting communications and suit leak checks. That whole process of ingress through suit leak checks lasts roughly 40 minutes, and that's when the hold releases and the countdown or the terminal clock picks back up again at T-minus 3 hours and 30 minutes. Again, because this is a test and the start of, or the point at which go is given for the start of tanking today was delayed, the L- clock that's in the upper right-hand corner of the screen, as well as what's out on the big lawn here at the press site, does not line up anymore with where NASA is with the tanking operations, it seems. So for the purposes of where NASA is, it's a little bit less clear when they would be hitting that hold for the real timeline that they're working inside the Launch Control Center. Again, NASA opted not to use a public affairs officer inside the LCC to provide real-time updates adjacent to the launch director. Instead, they are publishing updates on their live blog throughout the course of this wet dress rehearsal tanking test. Last update was published to the blog at 3:56 p.m. Eastern. So just about 30 minutes ago was our last official update from NASA. As you can see, the NASA helicopter is heading out across our shot here at the press site. The L- clock counting down towards the opening of the test window here at 9 p.m. Eastern. At this point in the count, if this were on launch day with the crew in the loop and the T0 was fixed to 9 p.m., the crew would be making their way out from the outside the O&C Neil Armstrong Operations and Checkout building here at the Kennedy Space Center, and just about ending their roughly 20-minute drive out to the launch pad. Per the original timeline, at L- 4 hours and 20 minutes, that's when the flight crew would head up to the White Room at the end of the crew access arm to get ready for ingress into the Orion spacecraft. Local time 4:40 here on the East Coast, 2140 UTC for those joining around the world. About 12 or 13 minutes ago was the most recent time that NASA shared the fueling graphic. So taking a snapshot from that again, recognizing that this was about 12 or so minutes ago, so things will have changed a bit since then, but you can see the current, or mostly current, levels of the liquid hydrogen and liquid oxygen on the core stage and the rocket's upper stage. About 3/4 the way filled on the core stage for liquid hydrogen, still about 1/4 of the way through on the ICPS. The last time that NASA showed this graphic about an hour or so ago. double checking the numbers, making sure I've got this right for you. At that point, the liquid hydrogen tank was, or excuse me, yeah, the liquid hydrogen tank on the core stage was right about where it is now at 76%. The hydrogen tank on the ICPS was at 24% filled. Again, that was the last time the graphic was brought up about an hour ago. So the core stage hydrogen tank has largely been unchanged in this past hour, and the liquid hydrogen tank in the ICPS has dropped about 1%. Meanwhile, liquid oxygen filling continues to move along quite nicely, approaching about 2/3 filled on the Interim Cryogenic Propulsion Stage. Latest from NASA coming down at 4:38 p.m. Eastern, 21:48 UTC. Core stage liquid hydrogen fill complete, entering topping mode. In their latest blog post, NASA says, and I quote, NASA teams have completed filling the core stage of the Space Launch System rocket with liquid hydrogen and transitioned to topping mode. Topping ensures the tank reaches its full capacity with super cold liquid hydrogen chilled to minus 423 degrees Fahrenheit. Engineers continue to watch the leak at the interface of the tail service mast umbilical, but the liquid hydrogen concentration in the umbilical remains within acceptable limits. End quote. local time just before 5 p.m. Eastern, 2200 UTC. We're coming up to the point at which, for the L- clock that is on the screen, it is counting down towards the opening of the test window, the earliest possible T0 that existed today at 9 p.m. Eastern, 0200 UTC. It'll be at that point when the 40-minute planned hold that was built into the original timeline will be released. The clock will pick back up at T-minus 3 hours, 30 minutes here in about 5 seconds. And the clock is resumed. As we are within the final 4 hours prior to the opening of the launch window here, you can see where things currently stand with the fielding progress on the SLS rocket. As you're watching Spaceflight Now's live coverage of the Artemis 2 wet dress rehearsal tanking test, see here on your screen the core stage has reached flight levels. The Interim Cryogenic Propulsion Stage has also reached 100% on its LOX tank. Liquid hydrogen on the upper stage still has about a third of its tank remaining to be filled. Local time 5:05 p.m. Eastern, 22:05 UTC. In NASA's latest update, timestamped 4:52 p.m. Core stage liquid hydrogen and liquid oxygen are now in replenish. Upper stage liquid hydrogen is in fast fill. Upper stage liquid oxygen is in topping. New blog update from NASA coming here in the last couple of minutes, saying, and I quote, fueling of the SLS, or Space Launch System rocket, is proceeding on all fronts following earlier pauses on liquid hydrogen flows. Liquid hydrogen and liquid oxygen in the core stage are in the replenish phase. Liquid oxygen has also reached the replenish phase on the upper stage. Replenish mode keeps the tank at flight-ready levels by replacing any cryogenic propellant lost to boil-off. On the upper stage, the liquid hydrogen fill has moved into fast fill. Following both stages of the rocket being in replenish mode, the launch director will assess readiness to send the Artemis closeout crew to the launch pad 39B to proceed with the Orion closeout operations, including hatch closures. End quote. If you're just now joining us, you're watching Spaceflight Now's live coverage of the Space Launch System rocket wet dress rehearsal. We're roughly 3 hours 45 minutes away from the opening of the test window today at 9 p.m. Eastern, 0200 UTC. At this stage in the count, the upper stage liquid hydrogen tank is currently in fast fill, and all other propellant tanks, those being the liquid hydrogen and liquid oxygen tanks on the rocket's core stage, as well as the liquid oxygen tank on the upper stage, or the Interim Cryogenic Propulsion Stage, are all in replenish. As the tanking test rolls on here at the Kennedy Space Center, we're also just a little less than an hour away from sunset as well. Those temperatures will begin to drop quite noticeably once the sun goes down. Sunset currently set for 6:03 p.m. Eastern, 23:03 p.m. UTC. Temperatures will drop down into the upper to mid 40s. And then following sunset will be in the mid to low 40s, trending towards the opening of the test window, where it's expected to be around 42 degrees Fahrenheit at 9 p.m. Eastern. local time currently 5:39 p.m. Eastern, 22:39 UTC for those joining around the world. It's been a little more than 30 minutes since our last update from NASA. The agency noting as 3 out of the 4 stages were in replenish, and that liquid hydrogen loading on the upper stage was still in fast fill. We'll have to wait until after the full rocket is in replenish before the launch director, Charlie Blackwell Thompson, will determine whether they will send the closeout crew to the pad to proceed with Orion closeout operations, like hatch closure. We're keeping an eye on the visibility of the closeout crew expected to pass by the press site, and as we see them, we'll do our best to make sure we've got our cameras trained and have a nice tracking shot for you. Per the original timeline of things, had NASA continued to target a simulated T0 at 9 p.m. Eastern, 0200 UTC, where we are right now at L minus 3 hours, just under 18 minutes, we would be just a couple minutes into the crew module hatch preparations and closure. The White Room closeout process would have been complete following the ingress of the flight crew, comm and suit leak check. About an hour from now is when, again, this is per the original timeline, which has since shifted a decent amount. But an hour from now, on the original timeline, was when crew module hatch service panel installation and closeouts would be conducted over the course of about 40 minutes. The launch abort system hatch closure process would start at about L minus 1 hour and 40 minutes. And the launch director, Charlie Blackwell Thompson, would hold her brief at L minus 1 hour and 10 minutes. On the nominal timeline, the closeout crew is set to depart from the pad about 45 minutes before T0. Again, at this point in the real-time wet dress rehearsal timeline, we are still awaiting confirmation that the closeout crew has been given the green light to head out to the pad. Last update from NASA coming just a hair past the top of the hour here, roughly 45 minutes ago from the timestamp of the update. Latest update, time-stamped 5:45 p.m. Eastern. The Artemis 2 Space Launch System rocket, all stages are now in replenish. Expanding on this from NASA, they say, quote, following the vent and relief tests on the Interim Cryogenic Propulsion Stage liquid hydrogen tank, NASA teams have entered into the topping phase of fueling liquid hydrogen. The vent and relief test verifies that the vent and relief valves operate correctly to maintain safe pressure levels inside the upper stage liquid hydrogen tank, while topping ensures the upper stage tank reaches full capacity. Following topping, teams will move into replenish mode, keeping the ICPS tank at flight-ready levels to the terminal count. Meanwhile, all other propellant tanks on SLS are in replenish mode. Just a little bit ahead of 6 p.m. here on the East Coast, as the sun is very much starting to set, as you can see here in this camera's view looking at the pad. Where we are right now compared to the opening of the testing window, NASA is running about 90 or so minutes behind. So if this were one of the launch days and NASA were counting down towards the launch of the SLS rocket, each launch day has roughly a 2-hour long window. So they would be most of the way through their launch opportunity if this were in fact a launch day, which of course this is not. time now, just a little bit past the top of the hour. You're watching live as the closeout crew, with their yellow lights on, is now departing from just adjacent to the press site here and are making their way out to Launch Complex 39B ahead of the work that they are doing or set to do in the White Room. Now, this work would be in preparation for the arrival of the crew if this were launch day and the crew were physically here in Florida. You could see some emergency personnel in the background and behind the closeout crew that will help support them. Among the members of the closeout crew is NASA astronaut Andre Douglas, who's one of the backup astronauts for the Artemis 2 quartet. Closeout crew lead, who, when you see the video of them working, he'll be wearing the number 1 on both of his arms just beneath the shoulder. Crew lead is Taylor Hose. And Andre Douglas will have the number 2 on his shoulders. We should be seeing the closeout crew arriving at the top of the mound at Launch Complex 39B in about 10 minutes or less. The departure of the closeout crew would signify, as NASA mentioned in its blog, that the Artemis launch director, Charlie Blackwell Thompson, must have given the go-ahead for the crew to depart, meaning that all 4 stages of the SLS rocket are now in replenish. The tower with the fire coming off of it, that is the hydrogen flare stack. Part of maintaining the proper pressure in the flow of things is burning off some excess hydrogen as needed. That's what you're seeing there on the bottom right-hand corner of your screen. Local time currently 6:41 p.m. Eastern, 23:41 UTC for our friends around the world. As the clock continues to tick down towards the opening of the test window today at 9 p.m. Eastern, 0200 UTC, because of the streaming limitations on YouTube, we are going to pause and pivot our live coverage coming up with a switch happening at the top of the hour, barring unforeseen technical gremlins. We should make a very seamless switch for you, the viewer, so you shouldn't have to do anything. We should be able to just port you directly from this stream into the next stream, and we'll continue coverage of the wet dress rehearsal tanking test of the Space Launch System rocket. Again, moving to the second stream at the top of the hour. The last update from NASA was time-stamped nearly an hour ago at 5:45 p.m. Eastern, noting that all stages of the Space Launch System rocket are in replenish. We did see the closeout crew depart for the pad some time ago. Per the original timeline of things, the closeout crew is set to depart to the White Room at L-4 hours and 40 minutes. On launch day, they'll be going through a series of operations to assist the flight crew in preparation for their getting ready inside the Orion spacecraft, donning their gloves and helmets, getting into their assigned seats, going through communications and suit leak checks, all during the planned hold at T-minus 3 hours and 30 minutes to lift off on launch day. Local time 6:57 p.m. Eastern, 23:57 UTC for those joining around the world. We saw the closeout crew depart from near the Kennedy Space Center press site for Launch Complex 39. Begin to make their way out towards the pad and potentially hold off in a staging area a little bit closer to LC-39B. In its latest update, timestamped 6:50, NASA says that the closeout crew now traveling specifically to the launch pad. It says the team will head to the white room inside the crew access arm on the mobile launcher. And they're responsible for securing the Orion spacecraft and ensuring all access points are properly configured before simulated crew ingress operations. So just looking back at the original planned timeline, let's see, the closeout crew to the white room was scheduled to happen at L-4 hours and 40 minutes. With Orion preparations for flight crew ingress originally on the schedule at L-4 hours and 25 minutes. So again, maybe a little bit of apples to oranges because it's not as clear where NASA is on its countdown timeline today, and they do have a 4-hour testing window as opposed to a 2-hour launch window on launch day. It seems as though if we're just comparing the update from NASA to the timeline right now, that they are roughly ballparky about 2 hours and 20 minutes off from the original time for the T0 at 9 o'clock. We're going to continue our coverage, though, on the other side of what we mentioned was going to be our flip from this stream and continuing into part 2. But don't go anywhere. You don't have to do anything. As soon as we end this stream, it'll shuffle you right on over to our wet dress part 2. So we'll be back with commentary once that begins.